but their host stars lives. The increasing number of potentially habitable planets suggests that such planets may frequently appear in the universe. And recently, scientists have discovered a planet only 22 light-years from Earth, with a similarity to Earth as high as 84%, and that is the planet Gliese 667Cc. According to Guglielmo Anglada Escude, an astronomer at the University of Göttingen in Germany, along with colleagues analyzing data on a star named Gliese 667 from the European Southern Observatory. This is a dwarf star 22 light-years from Earth with a surface temperature lower than the Sun. With a surface temperature of 3,400 degrees Celsius, much cooler than our Sun's 5,500 degrees Celsius. Therefore, this red dwarf star emits much less radiation than the Sun, achieving a brightness of just over 1% of the Sun's value. Including Gliese 667Cc, the scientific world has so far discovered only 4 planets capable of nurturing life. Kepler 22b 600 light-years from Earth, Gliese 581e 25 light-years from Earth, and HD 85512b 36 light-years from Earth. The habitable zone around a star is defined such that the temperature on a planet's surface is just right for water to exist in liquid form. Liquid water is considered one of the most essential requirements for the formation of life. Earth lies in a habitable zone around the Sun at a distance of 1 astronomical unit, i.e., astronomical unit. Due to much lower energy output, the habitable zone around the red dwarf star Gliese 667Cc is much closer to this star, with a distance of 0.11 astronomical units to 0.23 astronomical. Earth would be a frozen world if it orbited this star instead of our Sun. Fortunately, the planet Gliese 667Cc is closer to its star by 8 times. At 0.12 astronomical units, this places Gliese 667Cc in a comfortable and habitable zone. The planet Gliese 667Cc receives a radiation flux of about 90% of what we receive from the Sun here on Earth. Although much of this radiation is emitted in infrared, it is very likely sufficient to allow liquid water to exist on the planet's surface. However, the exact surface temperature is uncertain and depends on several unknown factors. Estimates: the surface temperature of this planet could be 30 degrees Celsius if we assume an atmosphere similar to Earth. However, a larger atmosphere would lead to higher temperatures and Venus-like conditions unfavorable for life. Therefore, further observation is needed to answer whether Gliese 667Cc truly supports liquid water and whether conditions on this planet are suitable for sustaining life. Due to the short distance to its central star, Gliese 667Cc orbits this star in just 28.15 days. Thus, a year on this planet is only 28 Earth days long. However, a day could be very long because this planet is very close to its central star. It is very likely that this planet is highly locked. It would rotate synchronously and always face one side toward the star, an effect we note from our moon. Therefore, there can be eternal day on the hemisphere facing the nearby star and eternal night on the other side facing outer space. The temperature difference between the two sides could be large and affect the planet's overall climate. The short distance allows the star to appear in Gliese 667Cc's sky much larger than the Sun in our sky. Moreover, Gliese 667 is part of the triple star system. The distance to the other two stars, Gliese 667A and B, is about 230 astronomical units, i.e., about 6 times the distance between Pluto and the Sun. There is a potential issue with the nearby host star. As studies show, many red dwarf stars, including Gliese 667c, are known to emit radiation bursts and energetic particles, which can be thousands of times stronger than our Sun. Such large flares can double the star's brightness in minutes. Life on the surface of Gliese 667Cc would have to find a solution to this problem, especially since the planet is close to the host star. Living on Gliese 667Cc would certainly be a completely different experience. The mass of planet Gliese 667Cc is estimated to be at least 4.5 times that of Earth. Like Kepler 22b, Gliese 667Cc is a super-Earth, i.e., a planet slightly larger and heavier than our Earth. Size and density are still undetermined,
suggesting the possibility that Gliese 667Cc could be a habitable gas planet.
Only smaller rocky or ocean planets with radii in the range of 1.7 to 2.2 times Earth's radius will be favorable for the formation of life.
The larger mass of this planet leads to a different gravitational acceleration compared to our Earth.
In the case that Gliese 667Cc is a rocky planet, the surface gravitational acceleration will be 60% higher than what we experience on Earth's surface. In other words, you would feel 1.6 times heavier. For example, a person weighing 75 kilograms on Earth would weigh 120 kilograms on Gliese 667Cc.
Moreover, a heavier planet can retain a larger atmosphere. Therefore, atmospheric pressure at the planet's surface would likely be higher. If Gliese 667Cc has an atmosphere proportional to Earth's atmosphere, the pressure would be several times higher.
For a more extreme case like a Venus-like atmosphere, the pressure could be several hundred times higher, corresponding to the pressure of water several kilometers deep in Earth's oceans.
Although Gliese 667Cc lies in the habitable zone, conditions on this planet could be very different from our Earth. Life would face several potential challenges that could include low and changing light conditions, possibly higher atmospheric pressure, and more intense solar storms. Nevertheless, even on our own planet, nature has shown us that life has an incredible ability to adapt to harsh conditions.
For example, the tardigrade, also known as the water bear. These tiny creatures range in size from 0.1 millimeters to 1.5 millimeters.
They are found in hot springs, ocean sediments, among ice sheets, and even on the Himalayas.
They withstand extreme temperatures from minus 273 degrees Celsius, absolute zero, to about 150 degrees Celsius. They can survive for years without water and endure radiation levels 1,000 times higher than other animals.
Although conditions on Gliese 667Cc may not be favorable for most life forms, there is still room for our imagination. We can only speculate about how flora and fauna, if they exist, would develop under the conditions on Gliese 667Cc.